Okay, so now we will solve some questions from our booklet. The very first question says, if a Mohr circle is drawn for a fluid element inside a fluid body at rest, it would be. So if our fluid element is inside a fluid body and which is at rest, so obviously it will follow Pascal's law, as I have told you. If the fluid is in rest, it will follow Pascal's law, and when it is following a Pascal's law, the Mohr circle will be a point. Okay, so this will be a point on the normal stress axis. Getting this? Like this. This will be our Mohr circle. Okay. Next question. Normal stresses are of same magnitude in all direction at a point in a field. Normal stresses are of same magnitude in all direction at a point in the field, then only when the fluid is frictionless, only when the fluid is at rest, only when the fluid has no shear stress, and in all cases of fluid motion. Okay, so if the normal stress is same in all direction, obviously the Mohr circle will be a point. We have already discussed. If the normal stress is same in all direction, equal in magnitude and direction, then obviously the Mohr circle will be a point. And if the Mohr circle is a point on the normal stress axis, obviously shear stress will be 0. Okay, so this will be C, only when the fluid has no shear stress. Getting this? Okay, next question. Next question says, the left limb of the machine shown below is subjected to 100 kilonewton of load. This load is given as 100 kilonewton. The diameter of the left limb is 10 centimeter and diameter of right limb is 1 centimeter respectively. The load to be applied at the right limb to keep the fluid at the same level is. So, similar question I have already told you during the theory part. Okay, so what we have to do is just equate the pressure. So, this will be W divided by area, which is pi by 4 into 10 square. This will be equal to force, which is F divided by area, which is pi by 4 into 1 square. Okay, so from here this F can be calculated. So, this will be equal to W is given as 100 kilonewton divided by 10 square, which is 100. So, this will be equal to force will be 1 kilonewton. So, on the application of 1 kilonewton of force, 100 kilonewton of weight can be lifted in hydraulic lifts. Getting this? Next question. The pressure in meters of oil of a specific gravity 0.8 equivalent to 80 meter of water is. Okay, so for this also I have told you that S1 by S2 is equal to H2 by H1. Okay, or you can say S oil by S water is equal to H water by H oil. Okay, so from here you can determine. So, this H oil will be equal to H of water, which is 80 meter of water given, into S of water is 1 divided by S of oil is given as 0.8. So, this will be equal to 100 meter. Okay, so, this 80 meter of water is equivalent to 100 meter of oil. Getting this? Next question. A 6 meter deep tank contains 4 meter water at bottom and 2 meter oil of relative density 0.9 above water. Okay, so we have got a 6 meter deep tank, and out of which 4 meter is water and 2 meter above is oil. This is 2 meter, this is 4 meter. Okay, you don't need to draw each and everything. Okay, you can mentally imagine and solve it very quickly. The pressure at the bottom of the tank, we have to determine pressure at the bottom of the tank. So, this pressure is because of this 2 meter of oil plus this 4 meter of water. Okay, so this pressure will be equal to rho GH of oil plus rho GH of water. Okay, so this will be equal to, for oil, rho is given as 900, relative density is 0.9 into 9.81 into height is 2 meter, plus for water 1000 into 9.81 into height is 4 meters. So, from here this will be equal to 58 kilonewton per meter square. Answer. Okay, so answer will be A. Clear? Next question. Which of the following pressure unit represents the least pressure? Millibar, mm of mercury, Newton per mm square, and kgf per centimeter square. Okay, so let us analyze this, and obviously you should remember these things. So, 1 millibar, as we know, 1 bar is 10 raised to power 5 Pascal, 1 millibar into 10 raised to power minus 3. Okay, so this will be equal to 100 Newton per meter square. Second is mm of Hg, 1 mm of Hg Okay, so 1 mm of Hg is how much pressure in terms of Newton per mm square, so is equal to rho gh. Okay, so this rho gh pressure will be this pressure will be equal to rho gh, so this will be equal to 13,600 into 9.81 into height. Height is 1 mm of Hg, so in terms of meter 10 raised power minus 3 meter, so this will be equal to 133 Newton per Newton per meter square. This term you should remember to solve the questions very quickly. 1 mm of Hg is equal to 133 Newton per meter square. Rest everything you can solve it very soon, but this 1 mm of Hg you should remember 133 Newton per mm square. Suppose 50 mm of Hg pressure is given and you have to determine directly in Newton per meter square, directly you can multiply it by 50. Getting this? Okay. Next, third is Newton per mm square. This is most common unit, which is called as megapascal. So this will be 10 raised power 6 Pascal Newton per meter square. Last is kgf per centimeter square. Okay, so 1 kgf is 9.81 Newton centimeter square, 10 raised power minus 4 meter square, or if I take it upward, it will be 10 raised power 4 Newton per meter square. Okay, so the least unit, as we can see, is 100 Newton per mm square, so answer should be A. Getting this now? Okay. Next question. The specific weight of the ocean water may be taken to vary according to the expression gamma is equal to gamma naught plus c root of h, where gamma naught is specific weight at the sea level and h is the depth below the sea surface. The pressure at depth h in excess of gamma naught is, this is gamma naught, in excess of gamma naught is. Okay, so we know what dp is equal to, as we have already proved, rho gamma into dh. Okay, so if the because the density is varying in this particular case, okay, that means this gamma is varying in this particular case. So if I want to determine this total pressure, so this will be, just integrate this, so this will be p is equal to integration gamma can be written as gamma naught plus c root h into dh. Okay, so just integrate it from 0 to h, from height 0 to h. Okay, so this will be equal to gamma naught into h plus c into h raised power 3 by 2, this is h raised power 1 by 2 plus 1 h raised power 3 by 2 upon 3 by 2. Getting this? Okay, now it is asked the pressure in excess of gamma naught. So pressure, because of this gamma naught, is gamma naught into h. So in excess of this pressure, so this pressure in excess of this gamma naught is equal to c into 2 by 3 into h raised power 3 by 2. Okay, so answer should be B, 2 by 3 c into h raised power 3 by 2. This is 3 by 2. Getting this? Okay. Next question. The difference in pressure head measured by mercury oil differential manometer of a 8 centimeter difference of mercury level will be, okay, 8 centimeter difference of mercury level, that means the value of x is given, and I have already told you the formula. This difference of height pressure head we have to determine, that means h1 minus h2 is equal to rho m by rho w minus 1 into x. Rho m is manometric fluid, rho w is density of the flowing fluid. Okay, so this difference in head we can determine it from here. This x is given as 8 centimeter, which is 0.08 meter into rho m, mercury level. The specific gravity of oil is given as 0.8. Okay, so rho m is 13.6, okay, divided by 0.8 minus 1. Okay, so from here this h1 minus h2 will be equal to 1.28 meter of oil. Answer. Okay, so answer should be C, 1.28 meter of oil. Getting this or not? Okay, next question. Next question says a U-tube open at both ends and made of 8 mm diameter glass tube has a mercury in the bottom to a height of 10 centimeter above the horizontal limb. If 19 centimeter cube of water is added to one of the limbs, the difference in mercury level at equilibrium is. Okay, so we have got one U-tube having 8 mm diameter, and initially the level of mercury is up to height 10 centimeter. Okay, so this height given is 10 centimeter. This is the initial condition. Now we are pouring water into it from one end, and after pouring water, that water will apply certain pressure on this mercury. okay, on one side of the limb, and there will be a difference in level of mercury in both sides. Okay, so the final diagram will be like this. Okay, so suppose the height of up to which the water is poured is h, the difference in mercury level is suppose x. Okay, so now first how can we determine the value of this h? So we know how much water is poured into it, 19 centimeter cube. So v is equal to what? V is equal to pi by 4 d square into h. Okay, so from here this h can be determined, 19 is equal to pi by 4 into d square, which is 0.8, the 8 mm in terms of centimeters, 0.8 into h. So from here this h will be equal to 37.8 centimeter, first thing. Okay, now how can we determine the value of this x now? So equating pressure at this level. Okay, equating pressure at this level. So here we'll be having rho gh of mercury is equal to rho gh of water. Okay, so from here this will be 13,600 into 9.81 into x is equal to, this will be 1000 into 9.81 into height of water column we have already determined 37.8. okay, so from here this x will be equal to 2.8 centimeter, answer. Okay, so answer should be B, the difference in level of mercury will be 2.8 centimeter. Getting this or not? Okay, next question says the cross sectional area of limb of U2 manometer shown in figure is made 500 times larger than the other. Okay, so area here is suppose A, so here the area will be 500 times of A, so that the pressure difference between the two limbs can be determined by measuring H on one limb of the manometer. Determine the percentage error involved. So what we are doing in this question is, let us understand this thing. We are increasing the cross section by suppose 500 times. So what will happen, whatever be the height, this height will be the change in height from in this larger cross section will be very less, and which can be neglected while measuring. So this makes the process much easier. That means we can measure it directly from one side just by measuring the height from one side. But still this is not 100% accurate. Why? Because if I am considering only this height h, okay, then I am neglecting this del h, this small change in height from this larger limb. We are neglecting this, the effect of this del h. Okay, so how much percentage error will be involved if I am measuring, if I am calculating the pressure just by measuring this height h? Getting the question or not? Okay, actual height which is changed is h plus del h, but we are considering only h for the sake of our convenience. We are considering only h. So how much error will be involved? Because here when the h height is raised here at the right limb, del h height will be fall in the left limb. Okay, so the actual change is h plus del h. Getting this or not? Okay, so for this we have to calculate the percentage error. That means we will have to calculate this del h by h into 100. This we have to calculate. Okay, so for this what we can do is, the volume fallen in the bigger limb or larger limb is equal to volume rise in smaller limb. Okay, so how much volume is there? So the area is 500A into height is del h is equal to, here total volume is small a into height is h. Okay, so from here this del h by h will be equal to 1 by 500, which is equal to 2 into 10 raised power minus 3. Therefore percentage change, percent error you can say, is equal to 2 into 10 raised power minus 3 into 100, which is equal to 0.2%. Okay, so this much percent error will be there if I am measuring the pressure just by measuring height h and not considering del h. Getting this or not? Okay, so answer should be C. Next question. Okay, so we have the question of inverted tube manometer. A pipe carrying water attest differential gauge deflection mercury gauge is 0.6 meter. Okay, the PA minus PB, this is difference in pressure, PA minus PB we have to determine. Okay, so how can we determine? So I have already told you PA minus PB is equal to rho m by rho w minus 1 into x. Okay, this is actually in meter of water, or you can say this is Pa minus Pb by rho g or Ha minus Hb. Okay, because finally we have to calculate it in terms of meter of water only. The options are given in meter of water. So Ha minus Hb is equal to Pa minus Pb by rho g is equal to rho m by rho w minus 1 into x. Okay, now the value of this x is given as 0.6 meter. Okay, so just put the value. So this will be equal to what? Rho m, which is mercury, manometric fluid is mercury, which is 13.6 divided by water is 1 minus 1 into x. X is how much? The difference in height, which is 0.6. Okay, so from here this will be 7.56 meter of water. Okay, so answer should be A, 7.56 meter of water. Okay, in terms of meter of water. In terms of kilopascal or pascal, we will have to calculate and multiply this by rho g, we will get Pa minus Pb. Getting this now? Okay, next question. What is the gauge pressure at P? We have to determine the gauge pressure in terms of oil column, in terms of meter of oil column. Okay, so I have already given you, we have already solved such questions during theory part. How can we solve such question? If we want to calculate it directly in terms of meter of oil. Okay, so directly we will solve it in terms of meter of oil. So this will be here, the pressure is P. Okay, now from here to here this will be minus, what is the distance given here? So this distance given is 60 centimeter, this distance which is given as 60 centimeter. Okay, or you can say 0.6 meter. So this will be minus 0.6 meter. This P is directly in terms of meter of oil. Just remember this thing. Okay, is equal to. Now here we have in terms of meter of mercury. Okay, so how can we convert it in terms of meter of oil? So into 13.6 divided by 0.85. Okay, the specific gravity is given as 0.85. Very simple. Okay, so you can see how quickly we can solve. Otherwise we would have to solve it in terms of kilopascal, then we will have to convert. So directly we can solve it in terms of meter of oil. If you want, you can directly solve it in terms of meter of mercury also, as demanded in the question. So here this P will be equal to 2.2 meter of oil. Okay, so answer should be D, 2.2 meter of oil. Okay, next question says, in the vertical limb shown, the rise H of the mercury is. Okay, so here we have to determine this H. The pressure here is given as 50 centimeter of Hg vacuum. Okay, this is a vacuum pressure given. Vacuum pressure means if I want to determine the absolute pressure, so this will be 76 centimeter minus 50 centimeter, as I have told you. I think this much absolute pressure will be there. Okay, so just equate the pressure at this level. Same thing, we have already done this. So here the pressure is, suppose here is P plus H in terms of centimeter of Hg only we are saying is equal to here atmospheric pressure, which is 76 centimeter of Hg. Now here the P absolute pressure is 76 minus 50 plus H is equal to 76. This 76 get cancelled out and H is equal to 50 centimeter. Simple. So answer should be A. Getting this? Okay. Next question. Okay. Similar question. The pressure at P of the bulb shown is, this pressure we have to determine. So how can we determine this pressure? And the answers given are in terms of centimeter of Hg only. So directly we can determine in terms of centimeter of Hg. Okay, so this will be P. Here we are equating the pressure here. P plus 26. Okay, is equal to the pressure here is 76 centimeter of Hg. So here this P will be equal to 76 minus 26, which is 50 centimeter of Hg. This much absolute pressure. Okay, so answer should be B. Clear or not? Okay. Next question. The pressure difference between point A and B for the setup shown in figure is. Okay, so we have to determine PA minus PB. Same thing, what we have to do is we will have to equate the pressure at this level. Okay, so how can we evaluate the equate the pressure at this level? Okay, so here we have the oil and here we have the mercury. So first we will determine it in terms of oil only, and then we will multiply it by rho into G. Okay, so in terms of oil, here we have total 31 centimeters, so this will be 0.31 in terms of centimeter of oil plus PA plus 0.31. Here pressure is PA plus 0.31 centimeter of oil is equal to PB plus 13 centimeter of oil is here plus 0.13 plus 8 centimeter of mercury is there, 0.08 in terms of centimeter of oil into 13.6, 0. Divided by 0.8. Getting this now? Now why we are doing this? Because directly we will have this in terms of meter of oil. So this will be equal to 1.18 centimeter of oil, sorry, 1.18 centimeter of oil, 1.18 meter of oil, sorry. Okay, on calculating this you will get 1.18 meter of oil. Now if you want to calculate it into kilopascal, just multiply it by rho g. So this PA minus PB is equal to 1.18 into rho is 800, 0.8 is the specific gravity, into G is 9.81. So this pressure difference is equal to 9.26 kilopascal. Okay, so answer should be A. Getting this? Next question. The pressure difference between points M and N for the manometer shown is, okay, the pressure difference in terms of centimeter of oil we have to determine. Okay, very simple to determine. So here we have PM minus this much height, 9 centimeter of height. Okay, 9 centimeter means 0.09 meter. Okay, but this is in terms of water, we have to convert it in terms of oil. Okay, so into specific gravity of water, which is 1, divided by specific gravity of oil, which is 0.83. Getting this? Not is equal to Pn minus this much height. Okay, so how much is this height? This much height up to this point. Okay, so here up to 12 plus 6, 18 centimeter we are having water, then after that 3 centimeter of oil. Okay, so this will be minus 18 centimeter of water, 0.18 into 1 by 0.83 minus 3 centimeter of oil. Okay, so from here this PM minus PN, this will be equal to 13 minus 13.84 centimeter of oil. Okay, so answer should be B. Getting this one? Okay, one more question of pressure measurement we will do. Now refer the figure. The pressure, determine the pressure, the absolute pressure of gas A at in the bulb. Okay, so we have to determine the pressure here at A. So how can we determine? In terms of mm of Hg. Okay, so in terms of mm of Hg, so this will be PA. What we will do is we will equate the pressure at this point, at this level. Okay, so this will be PA plus this much height, 10 plus 5 plus 2, 17 centimeter. Okay, in terms of mm of Hg, 170 mm. Okay, into this is oil, this is water, we have to convert it into mercury. So this will be into 1 divided by 13.6. Getting this? Not is equal to, here the atmospheric pressure is 760 mm of Hg plus the water up to height 5 centimeter. So plus 50 into 1 by 13.6 plus the mercury up to height 20 mm plus 20. Okay, so this will be, so from here this PA will be equal to 771.2 mm of Hg. Getting this? Okay, so answer should be A. Clear? So in this way you I think with this much question we have solved, you will now be able to solve each and every kind of question of this pressure measurement. Getting this? Okay, now coming to another type of questions. The total pressure on the circular plate of 2 meter diameter immersed horizontally in water or at a depth of 1 meter is. Okay, so we have got a circular plate which is placed horizontal. This is the cross section is circular. Getting this? Okay, so the force we already know is gamma A x bar. Okay, so this will be equal to 9810 into area of cross section, which is pi by 4 into d square of circle into 2 square. Okay, into x bar is nothing but this distance. So this depth is given as 1 meter into 1. So this force will be equal to 30819 Newton. Okay, but the answer, the option given is in kg. Okay, so just divide it by 9.81. So this will be 3140 kg. Okay, so answer should be B. Getting this? Just check the answer before determining the final answer. Okay, next question says a cylindrical tank of 2 meter diameter is laid with its axis horizontal and is filled with water just to its top. The force on one of its end plate in kilonewton is. Okay, so we have got one cylindrical tank with its axis horizontal like this. Okay, and this is filled with water up to top like this. Okay, we have to determine the force on one of its end plate in kilonewton. Okay, so we want to determine the force which is acting on one of the plate, this FH. Okay, so as we know, this FH is what? Gamma A x bar. So just put the value, simple, 9810 into area of cross section of this circular end, this area of cross section. Okay, so this will be pi by 4 into d square, diameter is 2 meter, 2 square into x bar is nothing but 1 meter from top, distance of centroid. Okay, so this will be equal to 30.81 kilonewton. Okay, answer is C. Clear or not? Okay, next question. The magnitude of hydrostatic pressure on one side of circular surface 1 meter area with centroid 1 meter below free water surface is. Okay, so we want to determine the magnitude of hydrostatic pressure on one side of circular surface. So same thing, F is equal to what? Gamma A x bar. Okay, now according to option, it would be better if we determine the value, because one of the option is 1000 kgf, so we can determine the value here. So this is equal to 9810 into area. Now what is this area? Area is given as 1 meter square, then x bar is also 1. Okay, and this option is in kgf, so in order to convert this into kgf, just divide it by 9.81, so this will be equal to 1000 kgf. I think we got the answer. Okay, so answer should be C. The force is equal to 1000 kgf. Okay, next question. The depth of center of pressure on a rectangular plane surface of 6 meter wide and 4 meter depth immersed vertically and its top edge touching the free surface of liquid lies at. Okay, so we have got the rectangular plane surface. This is our free liquid surface, suppose. Okay, now a rectangular surface is having the dimension 6 meter by 4 meter, immersed vertically, and its top edge touching the free liquid surface lies at. Okay, we want to determine the depth of center of pressure. Okay, so we know what depth of center of pressure, h bar is equal to x bar plus Ig upon A into x bar. Okay, now x bar here is 2 meter, this x bar is equal to 2 meter. Now we are adding this Ig upon A x bar in this 2, that means obviously this has to be between 2 meter and 4 meter. 4 meter is the total depth, so center of pressure will somewhere lie between 2 meter to 4 meter. Okay, so answer should be C, greater than 2 meter but less than 4 meter. Clear or not? Okay.